Welcome to AIMS India's online classes. Today in this session we are going to learn about light and sound. So already we have discussed about light and shadow, children. So we are going to learn more information about light in this chapter, and also we are going to learn about sound. Okay? Yes. So what is light? Like light has no mass and is not really considered matter. Okay, so light has no mass in the sense it does not have any measurement, or it does not have any property of any object. Okay, like we have liquids, like we have measurement, solids we have measurement, no, like in kilograms, in liters we are going to measure it. So like that, so we do not have any mass or no mass for light. Okay, it is just a form of energy. Okay, what is it? Light is a form of energy made of photons. Okay, so light is a form of energy. It is going to produce energy, and this energy is made of photons. Okay, children. So again, what are these photons? So photons are tiny little particles of light. Like you have dust particles. No, very small particles. But we will not be able to see very clearly. No. So like that, even photons are very little, very small particles, very small pieces of light. Okay. And all light is made up of photons. They are the fundamental particles of light. Okay, light. This is light, children. The concept of the photon was developed by Albert Einstein. Albert Einstein is a renowned scientist, children. So he has developed this concept of photon. So as you are able to see here in this picture, so these are the photons of the light. Okay, and they are very small in size. Okay, so which we cannot see, which we cannot see very clearly. Clear, they are very small in size, and these small particles, which we call as photons, they are the form of energy of light. Okay, and here in this light you have one characteristic, one feature of light. What is that? That is, it behaves like a wave. So one of the characteristic of light is that it behaves like a wave. You know what is wave? So when you see the water bodies, like especially sea, ocean or lake, you can see the water which is rising up and down. No, like up and down, as it is there in the figure here. You can watch this type of vision on the river bodies or sea, where the water is going to rise up and down. That is nothing but a wave. Okay, so here light also, it is going to behave like a wave. It also travels up and down. Clear, children? So as a result, what happens? Light can be defined by its wavelength and frequency. So because of this characteristic, that is light which can behave like a wave, so it can be defined, the definition of the light can be given by its wavelength. Okay, wavelength and frequency. And what is the frequency? The frequency is how fast the wave vibrates or goes up and down. So what is the wavelength, children? So wavelength is the distance between two peaks of waves. See here. So this is the wavelength, the distance between two peaks. See, here is a peak and here is a peak. Okay, and the peaks of the wave, that is the wavelength. And the frequency is how fast the wave vibrates. See here, the wave is vibrating here. No, the wave is vibrating. This frequency, like how fast or how slow it is moving. Okay, how fast the wave is vibrating and is going up and down. Are you able to see here? The red color one is the wave, the red color one is the frequency, okay, which is moving up and down on the wave. So that is known as the frequency, like how fast it is moving, okay. Frequency and wavelength are inversely related. Inversely is they are related opposite, on opposite directions. Like if like a low frequency wave has a long wavelength, and a high frequency will be having a short wavelength. See here, the distance between the wavelength is less, because here the frequency is moving, the frequency is very fast. No, so because this is high, here there is a short wavelength, whereas down here in this picture, so here you are having less frequency. See, the red color area is not that much fast as the above. So this frequency is less. So that is why the wavelength is like big. No, it has got a long wavelength. So frequency and wavelength travel in opposite directions, children. Okay. So if one is high, the other one will be low, and one is low, the other one will be high. Understood? Yes. Now, so the speed of light. So light travels. No, light travels. How does this travel? The light moves at the fastest known speed in the universe. So light is going to travel at the fastest known speed in the universe, okay, than any other object. Light is going to travel at the fastest speed, okay, children. And light travels in a straight path. Light is going to travel in a straight path. Are you able to see here? This is the straight path, which we call it as a ray. No, sun rays. The rays of the sun, which are going to fall on the earth in a straight line. No, path is nothing but the way. We call it as a ray. Okay. And speed of light in air. The speed of light in the air is of 2.99 into 10 to the power of 8 meter per second. Per second. See, you can just imagine how much is the speed of the light. 2.99. This is the decimals into 10 to the power of 8 meters. So, in this calculation, the speed of light in the air is going to travel per second. Okay, children? And now let us see the colors of lights. Okay, so what we are seeing when we see an object is reflected light. So when we see any object, okay, when we are seeing any object, it is the reflected light. So when light hits an object, some wavelengths are absorbed by the object and some are reflected. So any object, if light is going to hit, okay, it is going to hit, the wavelengths are going to absorbed by that objects, and some are reflected. Some are going to absorb, will not be able to see, and some are going to be reflected, where we can able to see. Okay, so for example, light of different wavelengths look like different colors to us. So as you can see here, these are of different wavelengths, okay, which we can see like a different colors, where we can see as different colors. So when we see an object of a certain color, that means the light of that color's wavelength is being reflected off the object. So for example, when we see a red shirt, the shirt is absorbing all the colors of light except for the red color. See, so here you can understand very clearly that if you are having a red shirt in front of you, if you are going to put or throw any colors on that red color, suppose you throw white, you throw black, or blue, yellow, green, you will be able to see all that colors. But suppose if you are going to throw the same color, the same red color on that particular shirt, you will not be able to notice that red color because it has been absorbed. No, the shirt has absorbed all the colors of light except the red color. Clear, children? Except the red color. So this is how we can say this. The light of that color wavelength is being reflected off the object. Okay, so that particular color, that particular object color is reflected off by that object. Clear, children? Now, white is a combination of all colors. So when we see white, the object is reflecting all the colors of light. No, so white is a very transparent color. No, whatever color you put on white and mix it up, so it is going to mix with all the colors. No, so that is why we can see it. The object which is white in color is reflecting all the colors of the light. You can have number of colors on white. Okay, children. Black at the same side, it is the opposite one. No, you cannot mix up other colors with the black. Now, if you mix green with the black, again you feel that is black in color only. Red in black, again you black only. There may be a little variation in the color, but the black color will be dominating. Whereas in white color, the other colors will be dominating than the white. Okay, children. So this is the thing. When we see a black object, that means almost all the colors of light are being absorbed. So whatever colors or whatever colors of light is there, it is going to absorb. Clear, children? Understood this? Yes. Now we'll see the reflection of light. Reflection of light. How the light is going to reflect. So reflection occurs when light bounces off objects. Reflection occurs when light bounces off objects. So when light is going to move, when reflection is going to occur, it is going to happen when light is going to move off objects. Okay, amount of light reflected depends upon how even the surface is. See here in the picture, you have got a flat screen. No, flat screen, that is like it is even. The surface of this object is even. No, so how much amount of light is reflected on this particular object is going to depend on how even is the surface of that particular object. Okay, so if the surface is rough, the light is going to scatter. In the sense, it is going to travel in different directions, scatter. Okay, and if the surface is smooth and flat, the light will bounce off it at equal angles. See here. So if the light is, if the object or if the surface of the object is smooth and flat as it is there in the picture here, the light will bounce off it all equal angles. See, the light rays are going to fall at equal angles if there is a flat and smooth surface of the object. Okay, and that is why a flat mirror reflects a good likeness of the object being reflected. So that is why, children, so we have got a flat mirror. So when you have a flat mirror, what happens? You will have a good reflection of the object. No, if the mirror is not flat and it is somewhere not even and very rough, no, then you cannot have a proper image. You cannot see our proper image. No, so because the light is going to scatter. The light is going to scatter. It is going to travel in different directions. Clear, children? So this is about reflection of light. And now we have got a refraction of light. Refraction of light. What does this mean? In each type of medium, medium is, for example, an object. Okay, so whether it is air, water, glass, like any material, any water, in every type of medium, what happens? the wavelength of the light changes. The wavelength, what is the wavelength? Like how does it travel? No, the wavelength of the light is going to change, but not the frequency. But the frequency is not going to change. So in the beginning we learnt that like a wavelength and frequency are going to travel in the opposite directions. No, or like they are opposite. But here in this refraction of light, what happens? The wavelength of the light is going to change, but not the frequency. Okay. So as a result, the direction and speed of the traveling light wave will change, and the light will appear to bend or change directions. So this is why what happens? The direction and speed of the traveling light. The direction, okay, the direction and also the speed of the traveling light wave is going to change, and the light is going to appear to bend or change direction. See here. So this is one container, children, where it is 3/4 filled with water, and you have just inserted one pencil in that water. But the pencil as it is in a slanting position, in a straight position. But if you feel that the pencil here from the water level, from here till the down, okay, the pencil is bent. No, are you able to see this clearly? Is bent. There is a little curve, but actually it is appearing like that. The pencil is not bent there. Okay, but the light is going to appear to bend. Okay, or to change the direction of the particular object. Okay, this is nothing but refraction of light. So you can observe, if you can take water in a glass of water and just insert a straw. Even though you are inserting the straw straight, but in the water you see that, or it appears like it is bent there inside the water, because here the light will appear to bend or change the directions. Clear, children? This is refraction of light. Okay. Clear? Now about sun. So what is sun? Most of the light on earth comes to us from the sun. Most of the light on earth comes to us from the sun. Again, sun here, what? Sun is a big star. A big star where it is giving us the light for the total universe. No. So most of the light on earth comes to us from the sun. And the sun shoots out billions of photons every second in all directions. And what are photons, children? Photons are very tiny little particles of light. No, photons are tiny little particles of light. So these photons, some billions of photons for every second, are being shot out in all directions. By which? By the sun. So the sun shoots out billions of photons every second in all directions, and the ones that happen to be pointed towards the earth come here. So to all the directions, like if you see to the north, to the south, to the east, to the west, in every direction, the sun is going to shoot out billions of photons for every second. But so what we are going to get on our earth is the ones that happen to be pointed towards the earth. No. So light travels in all directions, but which are pointed towards the earth, only that particular rays are going to come and fall on the earth. Clear, children? So this is how we get light. This is how we get light. Okay. And when these photons reach the earth, they first run into earth's atmosphere. So do you know, children, like earth is covered with a layer of atmosphere? No. So and we have got 5 layers of atmosphere. So we have already learnt some among them, and here again these photons which are reaching the earth, so first what they do, they first run into Earth's atmosphere. They first run into Earth atmosphere. See here. These are the layers like 1, 2, 3, 4, all these layers. Okay. So some of the photons get absorbed by the atmosphere itself. Some of the layers, like we have here, we are having one green layer, like we call it as ozone layer also. Okay, so where that ozone layer is going to protect us from this very harmful and powerful radiations which are received from the sun, that is the ultraviolet rays. Okay, so some of the photons get absorbed by the atmosphere itself, especially the ultraviolet ones whose wavelength is shorter. So what type of rays are going to absorb, children? That ultraviolet rays, that we call them as UV rays also. They are very harmful to our human body. Not only human, even any living organisms. No. So these ultraviolet lens, so this wavelength is short. Wavelength is short. Okay. And the frequency will be high. No. So we have learnt that when the frequency is high, then the wavelength will be short. Okay. And rest of the photons reach the earth surface. Okay. So rest of, apart from this ultraviolet rays, rest of some photons are going to reach the earth surface, by which we are able to get on this planet, light on this planet earth. Clear, children? So this is what we have learnt in today's topic. So we have learnt about photons, the light energy, wavelength and frequency, speed of light, colors of light, reflection and refraction of light, and also about the sun. So we will be continuing in the next session, children. Hope you have understood this. So take care and stay well, and goodbye. Please visit our website www.aimstoday.in for other information regarding online classes, quizzes, live worksheets, DIY activities, English classes and coding. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.